Season 2 of the Code Like an Architect series, Abstraction in Action.
One of the major benefits of abstraction is reduced complexity. In our 100 real life examples of abstraction, we already saw how abstraction makes things simpler for us in everyday life and removes a lot of unnecessary complexity. In this video, we will see how abstraction helps in reducing complexity in programming as well, making our lives easier as developers. We will see this at the object level and also at the architecture level. And in the end, we will go through an interesting batching example. It will give you a clear idea of how you can practically use abstraction to make your life and the lives of people around you easier. Let's begin. Tell me, what is this code doing? It's encrypting and decrypting a text. And how did you figure that out? You simply looked at the code and made sense of what it's doing. Now, what if I write the same code like this and ask you the same question? What is this code doing? The answer is still the same. But this time it's a little easier to understand. Why? Because now we are using abstraction. As a result, the code becomes more readable and easier to understand. Abstraction reduces complexity. Notice that when you come across code like this, you don't even need to open the methods and check their implementation. The interface itself is self-explanatory. As long as it does what it says it does, there is no need to step into these methods to uncover how it actually does it. In addition, you can reuse this code in as many places as you want, without getting into the complexity of the actual encryption or decryption algorithm. So, there are two approaches to writing code, either like this or like this. If everything is written like this, your code base will become very complex very quickly. But if everything is written like this, it will make your life and the lives of others much easier. Now think of an API endpoint in a client-server architecture that creates an order. Under the hood, there's an entire backend system at work. There can be databases, business logic, integrations, infrastructure, and much more. There are so many concerns involved, like how to scale this service, how to keep it maintainable, what the availability requirements are, how to keep it backward compatible, what the throttling limits should be, how to make it fault tolerant, performant, reliable, and much more. But as users of this endpoint, we don't have to deal with all that complexity. The client code can simply interact through this application programming interface. It doesn't even need to know what exists behind those endpoints. All it cares about is calling this endpoint, and the order should be created. Everything else is abstracted away. This endpoint acts as an interface that hides a lot of complexity from the client code. Suppose the backend of this service was originally a monolith, and later it was migrated to microservices. Earlier, it was deployed on a virtual machine, and now it's part of a cloud-native architecture. But again, as users of this API, we don't have to worry. We don't even need to know what's happening under the hood. As long as this API stays consistent and keeps doing what it's meant to do, the client code doesn't need to change. It remains completely unaware and completely unaffected. That's the power of abstraction. See how it quietly hides away all the complexity behind a simple interface. Let's keep going. Suppose in our microservices architecture, we are using an event-driven approach. When the order service creates an order, it publishes an event, order created. Other services like kitchen service, delivery service, and notification service subscribe to this event. Whenever the event is raised, the kitchen service prepares the order. The delivery service assigns a rider for delivery. The notification service sends a confirmation message. Now, think from the perspective of the order service. All it says is order created. What happens after that is none of its concern. Everything that follows is abstracted away. That's another example of abstraction. And once again, it shows how abstraction reduces complexity at every level and every layer of software development. Throughout this season, I have kept repeating and demonstrating that abstraction is not just an object-oriented concept. It's present everywhere. In these examples, you just saw abstraction in action at the object level and then at the architecture level. Finally, let's see another interesting example. This example will further demonstrate the concept of abstraction and show how we use it in real programming situations to simplify our day-to-day programming tasks. Do you know what batching is and why we use it? Let me explain. Suppose we need to read 1,000 records from a database, make some modifications, and then save them back. How would you do that? Would you read the records one by one in a loop, make changes, and then save them again one by one in separate round trips? Or would you fetch all 1,000 records in one go, modify them all in memory, and then commit the changes to the database in a single transaction? Of course, you would go for the second approach. It's much faster. Approach 1 would be very inefficient. It would take a lot of time and resources, while approach 2 is efficient and quick. It only takes 2 round trips to perform the entire task, whereas approach 1 would take 2,000 round trips to the database. So obviously you would go for approach 2, right? But what if there are 100,000 records, or a million, or even 10 million records? Now even approach 2 won't work. Handling such a huge amount of data in one go obviously isn't practical. For example, it would create enormous memory and might even throw an out of memory exception. It could create heavy CPU overhead. It might make the system lag and keep the database busy for too long, leading to timeouts, errors, or even crashes. The whole system would become heavy, slow, unreliable, and hard to scale. So, clearly, approach 2 won't work in this case. Then, what should we do? Should we fall back to approach 1, processing the records one by one? Of course not. Doing a million records one by one would take forever. So, even approach 1 isn't a solution. So, what should we do? In the case of a million records, neither approach 1 nor approach 2 will work. This means we need a third approach. And that third approach is batching. We will do this in batches, maybe 10,000 at a time or any other number that fits your particular scenario. Batching gives you the best of both worlds. You're neither doing it one by one nor trying to do it all at once. You are doing it in manageable batches. Now let's write the code. And that's what the code looks like. We are fetching 10,000 records at a time, modifying them, and then committing the changes. Then we wait for 5 minutes. After that, we fetch the next batch of 10,000 and repeat the process. This code will work, but we are not using abstraction, which means it's more complicated and harder to understand. It's also immobile, which means if we face the same scenario somewhere else, we can't reuse the code. We will end up duplicating the code and the effort every time, and we'll have to wrestle with all this complexity once again, which means more work, less consistency, and more bugs to fix. Now let's use abstraction. Let's create an interface following the abstraction design principle. This is how the interface may look. And this is the internal implementation detail. And here is how we will use this interface. I hope you can see the difference. That's what abstraction does. It elevates your code to an entirely different level. Your code becomes easier to understand, more readable, and self-explanatory. It hides all the internal details, in this case, the entire batching logic, behind a simple, elegant interface. Now, anyone can reuse this interface whenever they need batching, without worrying about the underlying implementation. That's how abstraction reduces complexity and makes our lives as developers so much easier. So, use abstraction and your code will start to look different. In the next video, we will explore another powerful benefit of abstraction: extensibility, the ability to build on top of existing abstractions. That's where its power begins to multiply. See you in the next video.